Welcome to the video presentation on LT distribution network breakdown maintenance, possible faults, identification and rectification. Greetings to all. I am Devraj Kundal, Assistant Manager, BSES Rajdhani Power Limited. Today, we will discuss and know about the LT faults, possible breakdowns in LT distribution network and their rectifications. We usually receive many complaints saying that there is no electricity in the house. We go to the house of the complainant and check to find out if there is really no supply. In this situation, we first check the display in BSES meter. If we notice that there is no light in the display of energy meter, we will check on the pole or underground cable or check the service line. Fault identification and rectification at consumer's premises. Let's identify the fault. First, we see if there is fault at consumer's premises against no current complaint. This is because the consumer reported that there is no electricity in their premises. Lineman visits the consumer's premises. Check the incoming service line by opening the meter box, where MCB is installed and connected. He checks the availability of supply at MCB terminals. On opening the meter box, he observes that there is a lot of rat dung on the base plate of meter box. Rats have damaged the incoming control cable at the entry point. On further checking, he observes that the neutral is missing and finds that rats have cut the neutral wires at cable entry point of the meter box. Lineman checks the availability of supply at meter board in the presence of consumer. The lineman is showing the consumer that supply is available up to his MCB from the meter terminal. In many cases, there will be no supply at consumer's MCB from meter. In that case, the lineman checks the service line from feeding point. He checks the busbar box, where service line is connected from the meter. On opening the busbar box, the lineman finds loose connections and temporary joints. Busbar strips are missing and incoming and outgoing lines are jointed and tapped. 2 outgoing service lines are cut from the joint. Outgoing leads are overheated and damaged. Supply is missing from busbar boxes. Leads are temporarily jointed. Incoming service line is damaged at busbars and overheated at joint. The joint of incoming service line is loose and the circuit is open from the feeding point. Similar condition prevails at pole, where due to jumbling of service lines and excessive stress on cables, there is a no current complaint. It is very challenging for a lineman to attend a fuse call or no current complaint in such a bad condition of wiring. He is unable to identify the particular consumer's outgoing line from meter. There are also safety issues. Now, let's look at defective meter cases and how consumer supply is affected. A flash occurred at meter terminal. Smoke and black soot is clearly visible. These are cases where the meter is burnt. The consumer's electricity supply was interrupted due to short circuit at meter terminal, R-phase terminal of meter, and both incoming and outgoing leads are overheated and burnt. The worst thing that can happen when a heavy flash occurs in meter box with fire is the complete damage of metering equipment. Instead of making temporary joints to restore the consumer's supply from busbar, ensure that there are firm and tight connections with sockets. There should be no jumbling of wires, which is major cause for breakdowns due to loose and temporary connections. The following are the corrective measures. Energy meters are installed in a row with clear and distinct gaps. Both incoming and outgoing cables are properly saddled with clear visibility from their feeding points. Meter terminals are tightly connected and covered with seal, and there is no joint in the incoming cable. To avoid many service lines from a single pole and to avoid jumbling, pole mount distribution boxes are commonly used. Here you can see that 2 distribution boxes are fitted on the pole. Also, using service cable anchor not only reduces stress on the cable but also reduces extra length and jumble of cable at top of pole. Clamp the service cable up to the meter box emanating from pole. Avoid the hanging of service lines. Lineman replaces the control wire of meter, which was damaged by rats. They ensure to apply M-seal at cable glands to avoid the entry of reptiles from cable entry point of the meter box. The consumer supply is restored. Testing of meter and readings is being carried out in the presence of the consumer. In this way, clean and tidy wiring makes it look aesthetic. It not only reduces no current complaints or fuse calls, but also saves electricity waste due to loose joints and overheating of connection leads. You can see that a lineman is repairing the LT service cable emanating from transformer to consumer premises. A flash has occurred at the LT cable end box of transformer, causing damage to service line cable insulation. Before a new service line can be laid to consumer premises, a TCR, temporary current restored, is being prepared by breakdown staff. This is done by tapping at the insulation tape on damaged portion of service line cable lead. If the service line is in good condition, we will check the MCB of the consumer. MCB is checked thoroughly to know whether there is fault in the input terminal or outgoing terminal. If the fault is in input terminal, we will thoroughly check it, repair it and provide supply to the consumer. If the fault is in outgoing terminal of the MCB, that will be the fault at the consumer end and will be informed accordingly to consumer. The consumer will get the fault rectified. Another type of complaint that we receive is about power failure in whole area or block. If we receive such complaints, we can be sure that the fault is from our end and could be a major one. Power failure in whole area. Such fault can be classified as force majeure, that is, due to natural calamities like storm, floods, earthquakes and so on. Other reasons could be short circuit by birds called birdage, electric pole hit by vehicle or someone damaged the underground cables during digging. Civic agencies carry out unscheduled digging along the cable route to lay their gas, water or optic fiber lines. They often damage the electric cables. Let's see some breakdowns due to natural disaster. This is case of storm where LT lines are damaged due to uprooted tree falling on the cable and road. Apart from supply failure, there can be severe traffic jam. LT lines are lying on the road. Breakdown staff make a temporary barricade by placing their van in the center road. This is to avoid heavy vehicle passing over the falling lines. On the other side, they placed tree branches as barricade. Due to a severe storm, a communication tower gets uprooted and falls on the wall of an electric substation. Due to immense pressure, the wires snapped, including the LT lines. A tree has fallen on the LT lines near a pole-mounted substation. LT lines snapped and are badly damaged. Here, due to the uprooting of a tree and its impact, the LDPC pole got uprooted and LT overhead line is touching the ground. This is a case of a Boeing aircraft force landing in field of urban area. It hit a tree which fell on electric lines. Here, a tree fell on the LT lines and blocked the road. This is an LDPC pole hit by a vehicle in a small lane. The pole is broken. You can see that the street light fixture accessories and the wires are damaged. These are emergency situations. Hence, the breakdown staff has to restore the supply to make the system normal. Let us see how the system is being made normal. The defective portion of system is sectionalized. New poles are being erected and the lines are being shifted to new poles in the flood-affected area with the help of a crane. New LT lines are being laid to restore the supply. With the help of cranes, the uprooted trees are being removed. Roadblocks are being cleared. A broken tree is being lifted with the help of a crane to remove it from the lines. The branches of trees are being lifted and taken away by crane. This is case of LDPC pole broken and uprooted. It has been hit by a tractor trolley. You can see that the lowest conductor line snapped and has fallen on the ground. This LT feeder tripped from the substation due to earth fault. Thus, entire area has no electricity. The breakdown staff has to arrange a new 9-meter PCC pole for replacement. They will have to take permission for emergency shutdown of HT feeder also, as LT lines are leaning over the HT pole, and for erection of new LT pole. The electric supply of the area should be restored within 6 hours as per regulation. LT poles are being carried in a pole cart for replacing the broken poles. If we receive such no current complaint for a whole area, we check the ACB and then do area patrolling. During area patrolling, we first check the overhead lines to check if there is any fault. If any fault is found in the line, we rectify it and close the complaint. The complaint will be closed after the ACB is on and the supply for the whole area is restored and made normal. If there is repeated tripping due to overload or short circuit, the ACB functioning becomes weak. This results in damage, flashing, and so on. In such cases, the breakdown staff bypass the burst ACB. Then, they try to restore the supply and take up the task of replacing the old ACB with a new one. Here, you can see an LT switchboard panel. It is manufactured in 1989 and has fuse units for housing HRC cutouts. Thus, it has become obsolete as on date. You can see waste scrap lying in front of the panel. Porcelain insulator bobbins are cracked and the rubber housings are dried up and eroding. The reliability of LT switchgear becomes susceptible for operation. The lineman is confused as to how to take up the job. This is because all the components in the panel are on the verge of collapsing. Thus, repair is not feasible. Look closely now. The lineman is operating LT switchgear in view of safety hazard. The ultimate solution is to replace all old off-date panels with new ones. Here you can see that the complete LT panel has been replaced with new ACB. Each LT feeder is having individual ACB. Their tripping mechanism has been set according to their load profile. In this way, the system is made reliable and efficient. Let's see the comparison between old and new panels. Here, you can see the old bulky panels. There is only one LT main switchgear having one incoming line from the transformer LT side and 3 outgoing feeders, where one is faulty. Repairing the LT bus is a tough task. This is because of non-availability of obsolete accessories. Moreover, repairing it takes a lot of time, and after repair, they have very low reliability. In this case, all the feeders mentioned above are replaced with new ACB. These are easy to operate and efficient. This is an LT ACB of 400 amperes made by Larsen and Toubro. It has setting at 75% in its tripping relays. We are going to energize the ACB after cleaning the dust and washing the arc chamber with CRC. If the frequency of complaints increases in an area, it means that the fault is not inside the individual ACB but in the LT main. In this case, we check the LT main for the second time and do patrolling in the area. There are 3 types of LT mains in general according to distribution transformer capacity. They are 400 kVA, 630 kVA and 990 kVA respectively. In 400 kVA transformers, 800 ampere LT main is installed. In 630 kVA transformers, 1250 ampere LT main is installed. And in 990 kVA transformers, 2000 ampere LT main is installed. The LT main setting is done at 80% to avoid overloading. If a fault arises in this condition, we patrol the area to check for unbalanced load, brigade, jumpers snap, breaking of neutral and so on. Most of these complaints are due to neutral breakdown. In that case, we check the neutral, connect it properly and connect to the jumper properly. Then we go to the substation and switch on the LT main. This is how we complete an LT breakdown complaint. Let's have a close look at an LT overhead network. You can identify the fault in case of breakdown as you can see the complete network. We start from the dead end of LT pole. You can see that there are 5 ACSR conductor lines wound over shackle insulators on D clamps. The upper 3 heavy conductors are 3-phase lines. The next one is a low-size conductor for street light. The 5th one is neutral and lowest is GI wire, which guards all the above wires. This is called earth or ground wire. Each ACSR conductor is connected with extension loop. In local language, it is called ghodi. All the interlinked connections to the lines are made from these extension loops. When we proceed to the next span, which meets at T point, these are connected with jumpers through extension loop or ghori. These jumpers act as isolation points of each pole line. The faulty portion of a distribution line is thus isolated. All the service connections to the consumers are connected on extension loop. This is for easy isolation and least effect on main line conductor in case of a fault. This is an LT control panel in a substation. You can see that there is an LT main connected from the transformer outgoing. It is distributed to a number of individual feeders like outgoing feeder to street light, zonal office, school, and others. In case any fault occurs either in earth or overcurrent overload, the individual feeder gets tripped. You can see that this is outgoing feeder for the capacitor bank. It controls the voltage regulation of the transformer. We get different types of complaints such as low voltage, high voltage or fluctuations. Here you can see how the field staff checks the status of LT lines. They are equipped with multimeter and clamp-on meter. Checking of the line condition by multimeter and clamp-on meter. Checking of the line condition by multimeter and clamp-on meter. Checking individual line status of voltage and current. The on-line status is displayed on the multimeter. In these conditions, we will do area patrolling to find out the cause of complaint. It may be due to unbalanced load, jumper snap, neutral breakdown, face-to-face short circuit or DD fuse blow on HT side of distribution transformer. The engineer checks the phase current with the help of clamp-on meter. In case of unbalanced load, the load in RYB phase should be properly balanced and the current in neutral should be zero ideally. However, 20% of total phase current is allowed. Suppose there is unbalanced current. In one phase, 100 amperes is there and in another phase, 20 amperes is flowing. In that case, the current flow increases in the neutral and problems arise. When a jumper snap occurs, we get a complaint that one phase is missing and there is overvoltage in another phase. In that condition, we immediately switch off the LT main, repair the jumper, rectify the problem and switch on the LT main. Then we check that supply is restored as desired. This is how such complaints are resolved. When we get a complaint that DD fuse is blown, the voltage in the LT main of that particular phase of the blown fuse becomes very dim. In that case, we immediately switch off the transformer, call the HT breakdown, repair the blown DD fuse and resolve the complaint. In this video presentation, we have learnt that LT distribution network, importance of balanced load, neutral current, maintenance, possible faults, causes for faults, identification and rectification of faults in the LT distribution network.